Right, let's get into this explainer and master the exact steps required to execute the National System torque setting procedure immediately following a rig move. Because the second that rig reaches its operational air gap, the real work begins. And out here, precision is absolutely non-negotiable.
Here is our exact operational workflow for today. We'll start with the 24-hour countdown, move into testing and measuring torque, then we'll master the equalization math, tackle the brake holding capacity check, and finish up with the final solenoid check. Let's hit it.
All right, kicking things off with Section 1, the 24-hour torque countdown.
The moment your rig hits that operational air gap, boom, the clock starts ticking. First things first, obviously, get your job safety analysis completed immediately. You know the drill. You can't even look at a wrench until that JSA is approved. But once it is, you've got exactly a 24-hour window to complete this procedure and secure the system. It's not a ballpark suggestion. It is a hard operational deadline to guarantee the rig's structural integrity.
And inside those 24 hours, you and your partner have to systematically retorque all 36 gear units. Let's be honest, it's a massive physical workout. Because of the sheer volume we're talking about here, the absolute gold standard is having one person dedicated to manhandling that heavy torque wrench while the other operates the brake release bar. It just makes the whole thing safer and way more efficient.
Moving right along to Section 2, testing and measuring torque.
Okay, so after you pop the dust cap off the brake cover, your very first physical task is to rapidly pull the brake release knob on and off. Now, you're not measuring numbers just yet. You're actually listening for some very distinct sensory cues. Hear a really loud snap? That means you're dealing with high torque. Just a quiet click? That's low torque. You want to pop that release until you are absolutely confident the torque is in a manageable, controllable range before you ever even think about applying a wrench.
Now, this next point is absolutely crucial. Before applying any force, you have to note this critical safety marker from the manual. The brake shaft extension rotates in the exact same direction as the climbing pinion. You literally have to visually confirm this co-directional movement. If you get this backward, you're just fighting the gear system instead of adjusting it, which is pretty much a guaranteed way to wreck your equipment.
So, working systematically through all 12 motors on a leg, one of you will work the release bar while the other reads the momentary torque and jots it down on the motor torque worksheet. Basically, you pull the bar to momentarily release the brake, read the holding torque on your wrench, let go so the brake re-engages, and then log that exact number straight into the old column of your sheet.
All right, Section 3, Mastering the Equalization Math. This is where we get to the absolute heart of the motor torque worksheet. This is where those old numbers transform into actionable targets, and precision here is everything. Just follow this 4-step equalization formula flawlessly. Sum the readings from all 12 motors on the leg. Divide that total by 12 to get your average. Then, add exactly 3 foot-pounds to that average. Bam! That final number is your precise new target for every single motor on that specific leg.
Let's actually look at that math in action, right? Let's say you sum them all up and get 2,160 foot-pounds. Divide that by 12, which gives you an average of 180. Then, just add the required 3 foot-pounds, and you end up with a zero-ambiguity target of 183 foot-pounds. That is the exact number you need to dial in for every single motor on that leg.
Now, as you go back and adjust each motor to hit that new target, you're going to use 2 totally different physical actions depending on where you started. If your old reading is above your new target, say above that 183, you release torque by completely removing the wrench and popping the brake. But if it's below the target, you apply the wrench to the shaft extension and manually add torque until you hit it right on the money. And hey, a massive warning right here. Every single leg on the rig is going to have its own unique torque target. Do not fall into the dangerous trap of setting all the legs to the same torque value just to save a few minutes. Seriously, the rig's center of gravity means each leg is carrying a completely different load, so you must calculate and adjust each leg completely independently. Moving right along to Section 4, the brake holding capacity check.
So, just when you think you're totally done with torque, the monthly brake holding worksheet throws a curveball into the mix. It's actually super easy to confuse this with equalization, but there's a huge distinction here. Equalization is all about balancing the workload across your motors. The holding check, that measures the literal physical health and friction capacity of the actual brake discs inside the unit. Because we're testing the discs themselves, your workflow completely flips. You keep the brake set, force it clockwise, force it counterclockwise, and then average those two measurements. Did you catch that? Do not release the brake. You want it fully engaged because you need to physically test exactly how much force it takes to overcome the friction of those discs in both directions.
And these numbers are your hard, drop-dead minimums. For the 30 horsepower motors, if your average comes in below 313 foot-pounds, you have to disassemble that brake immediately. For the 20 horsepower motors, the absolute floor is 166 foot-pounds. If you dip below those lines, your disc capacity is officially compromised. There's no gray area here, no waiting around. It is time to tear the brake down.
Finally, wrapping up with Section 5, the final solenoid check.
Okay, after all your torque procedures are totally buttoned up, your absolute final task before calling it a day is verifying the solenoid air gap. You're measuring the distance right between the lower edge of the plunger and the top edge of the solenoid frame. Now, technically, anywhere from 1 1/4 to 1 1/2 inches is acceptable, but you really want to strive for that absolute sweet spot of 1 3/8 inches. That's going to give you optimal mechanical release performance.
As you're wrapping up your worksheet, keep this in mind. A declining torque trend over time, even if it's currently sitting comfortably above the minimum, is your early warning system. Schedule that preventative maintenance before a failure forces your hand. Don't just sit around waiting for a motor to drop below that 313 foot-pound threshold. Use the data you gather today to track wear over time and stay ahead of the curve. So I'll leave you with this. Are you actively tracking your holding trends, or are you just waiting for a breakdown? Use the numbers, be proactive, and keep your rig safe. Thanks for tuning in to this explainer.